Okay, picking back up at problem number 3. It is the last one that is the formal definition on this review. So again, the limit as h goes to 0. Here comes f of x plus h minus f of x itself all over h. Now, the silver bullet when it comes to dealing with any kind of irrational equation is to take the numerator as it stands, but change the sign in the middle between them. Now, if we go ahead and we distribute that, this root times exactly the same root is going to basically make the root go away. The outer and the inner, I've got basically root a times root b and minus root b times root a. Those two pieces are going to cancel out. But then the last piece is going to be 2x minus 1 times root 2x minus 1 is just going to be 2x minus 1. Now, I'm going to just keep moving across the top here for a second because I notice that I have a 2x and a negative 2x. I have a negative 1 and a positive 1, so literally the entire numerator reduces down to just plain old 2h. And the denominator has h and this entire conjugate argument that we have right here. Again, I have not actually dealt with this quite yet. But what we are going to notice is when you do, you have h times all of this stuff that we have right here. The h is going to cancel, and we're left down with 2. But as h goes to 0, this is root 2x minus 1 plus another root 2x minus 1, which is 2 roots of those 2x minus 1s, which, again, you can see quite clearly that those 2's would cancel, and there is my derivative. Fairly straightforward. Now, of course, if I wanted to find g prime of 5, I just need to plug 5 into that derivative. So g prime of 5 would be 1 over the square root of 2 times 5, which is 10, minus 1. That's 1 over root 9, also known as 1/3. So the slope of my tangent line would be 1/3. Now, normal is an interesting word because it's really a fancy way of saying perpendicular. So just like before, we want a slope, and the normal slope should be opposite and reciprocal. I also need a point. So if I plug 5 into the original problem, 2 times 5, 10, minus 1 is 9, so that's going to be 3. So now I can do y minus the y value, x minus the x value, and then the slope of the normal is negative 3. Keep in mind that if we had used this slope, that would be the slope of what we call the tangent to the curve. Now, moving on to number 3, the second 3, I guess. I just realized that this is 3a, and this is the other number 3. That's kind of funny. Is when we find h prime, remember this is a quotient, but in a derivative, you can always take constants and put it in front. So I'm just going to let that sit in front. And so this is a quotient, so the derivative of h is going to be low d high. That is going to be g times f prime, there's low d high, minus high d low. We're going to square the bottom. And of course, away we go. And so we have the derivative sitting there. There's my low d high minus high d low, square the bottom. And now we just need to cherry pick values out of that table. So g of 3 looks like g of 3 is negative 1. F prime of 3 is going to be negative 4. F of 3 is 7, and g prime of 3 is negative 1/4. And then, of course, we need to square the bottom, and away we go. So if we square the value for 3, we're looking at the number 1, and we're good to go. See you guys. So that's going to leave me with 5. I guess negative 1 times that is positive 4. We got 7 times 1/4 is 7/4 all over 1. This is starting to look a little bit boogery. Hopefully this comes out okay, but I got, when I did my work a little bit ago, I got 114 over 5. That feels wrong to me. 115 over 4. I just read my notes wrong. 115 over 4. Now for J prime, J is not actually a quotient rule. It's literally just the definition of chain rule. So it'd be f prime of g of x times g prime of x. And f prime of g of 3, but g of 3 again was -1. And g prime of 3 is -1/4. And we're just going to go one step further because f prime of -1 is -2. And -2 times 1/4 is 1/2. So if we're going to find the equation of the tangent to the curve, we first need to find out what is the point. And so if I plugged 3 into h of x, h of 3 is just 5 times f of 3 over g of 3. So f of 3 was 7. Let's see, let's get that up there a little higher. So I'm doing h of 3, which is 5 times f of 3 over g of 3, and g of 3 was -1. So I got -35. So when I plugged 3 into the curve, I got -35 out. And so we have a point, which is y minus the y value, x minus the x value, and I think we already found that h prime of 3 up here was 115 over 4, and that's going to be my slope right there. All right, maybe we can do just a little bit more. Number 4, it is the proof that the second derivative of the cosecant is cosecant cubed, cosecant x cotangent squared. So here we go. If we take the derivative of the cosecant of x, this is a memorized fact that the derivative of cosecant is negative cosecant cotangent. So if we are now going to take the derivative of cosecant cotangent, remember we're going to think of that as an f times a g. This is again going to then be product rule, which is going to be f prime g plus g prime f. So again, the derivative of a negative cosecant is going to be positive cosecant x cotangent x times g itself, which is cotangent, plus g prime. Now, let's be careful. The derivative of a cotangent was a negative cosecant squared times the first, which is a negative cosecant. So here's f prime g plus g prime f. Putting that all together, it looks to me like I've got a cosecant and a cotangent squared. That's cosecant x cotangent squared x. And a cosecant squared times a cosecant would be a cosecant cubed of x. Check. I think we got it because that lines up perfectly with what we did right here. And that kind of ends number 4. And I will be back with the next video for the next piece. All right, see ya. Bye-bye.